Bismillahirrahmanirrahim. Assalamu alaikum, dear students. We are studying Cambridge International AS and A-level mathematics. The syllabus code of which is 9709. Today is our lesson number 7. These are the questions of lesson number 6, and there are the answers of these questions. Hope you have solved these questions. Today in this lesson we will study discriminant. What are the lesson objectives of today's lesson? After this lesson you will be able to know the definition of discriminant, why it is called so, and you will be able to know what are the uses of discriminant. Now, discriminant in mathematics. In mathematics, the discriminant of a polynomial is a quantity that depends on the coefficients and determines various properties of the roots. Roots means solutions of the polynomial. As you know that every quadratic equation has two solutions or roots. Every linear equation has one solution or root. So it determines various properties of the roots. The discriminant of a polynomial is generally defined in terms of polynomial function and its coefficients. Why it is called so? Why discriminant is called discriminant? It is called discriminant because it can discriminate between the possible nature of answers. Discriminant of a quadratic equation. Now in your syllabus this is the discriminant of quadratic function or equation. The standard quadratic equation ax square plus bx plus c can be solved by using quadratic formula. This is the quadratic formula. You are familiar with this formula. X is equal to minus b plus minus b square minus 4ac over 2a, where a, b, c are the coefficient of this function, this equation. There are normally two solutions of the quadratic equation. So this discriminant is the part of the quadratic expression underneath the square root symbol. So this expression which is underneath the square root symbol b square minus 4ac is called the discriminant of this expression or equation. Discriminant we can write d is equal to or dic b square minus 4ac. This expression is called discriminant. Discriminant and nature of roots. How you can determine the nature of roots without solving the equation? The discriminant tells us the number of solutions of a quadratic equation that will have without having to actually find them. That is the number of roots, number of solutions of the quadratic equation can be determined by using the discriminant without actually finding the roots or without actually solving the equation. It tells us whether there are two roots, one root or no root. You know that quadratic equation can have a maximum of two roots. It may have one root or it may not have any root, any real root. And secondly, discriminant tells us what type of roots the equation has, whether the roots are real or imaginary. It tells us whether the roots are real or imaginary. You know that when the expression within the square root is a negative number, then we say that there is no real root or solution, because the square root of a negative number cannot be determined. Different cases of the determinant. Now b square minus 4ac, when you will solve b square minus 4ac, or when you will find b square minus 4ac, that is the discriminant, if this answer is equal to 0, so it means there is only one real root or solution of the equation. And in this case, graph touches the x-axis at only one point. That is, x-axis is a tangent to the graph. You know the graph of a quadratic function is a curve, and we know that a line that touches the circle or curve at only one point is called tangent. So if discriminant is equal to 0, then there will be one root and graph will touch the x-axis at only one point. And we can also say that x-axis is a tangent. When it will be said that x-axis is a tangent to the function, so it means there is only one solution of the equation. And if b square minus 4ac is greater than 0, then equation will have two distinct real roots. That is, graph crosses through the x-axis at 2 points. In other words, you can say graph touches the curve at 2 points. And if b square minus 4ac, that is the expression or number within the under the square root sign, is less than 0, that is negative, then there will be no real root and graph does not cross the x-axis. Graph will not touch the x-axis. These are the three cases. If b square minus 4ac is greater than 0, graph crosses x-axis at 2 points. One is this and other is this. Both may be positive, both may be negative, or one positive or negative. Now in this case, this parabola opens up. The parabola may open down and can cross x-axis at 2 points. B square minus 4ac is equal to 0, then tangent to x-axis, that is this graph touches x-axis at only one point, and this is the point of contact. And if b square minus 4ac is less than 0, that is it is negative, then graph does not cross x-axis. This is the case. So you have to keep this in mind. If equation has only one root, so it means its discriminant is equal to 0. If equation has two distinct real root, it means the discriminant is greater than 0. If equation does not have any root, then it means discriminant is less than 0. And in case when discriminant is 0, it means it has only one root. When discriminant is greater than 0, it means equation has two roots and no root in case of discriminant is less than 0. So you have to keep both way in your mind. Sometimes it is said that the equation has one real root, or equation has two real roots, and you are asked to find the value of some constant. So we have to put, if it is said that equation has one roots, and we will put discriminant equal to 0 and we will solve to find the value of unknown. And if we are asked to find the value of unknown such that the equation has two distinct roots, we will put discriminant greater than 0, and this will become an inequality, and we will solve inequality to find the values of the unknown. Uses of discriminant. Discriminant can be used to solve quadratic inequality. Can be used to solve quadratic inequality. And discriminant can be used to solve simultaneous equations, including one linear and one quadratic equation. When there are two equations, simultaneous equation, such that one is linear and one is quadratic, we can use to find the value of unknown to solve these two simultaneous equations. Now let's solve an example. In this example, you are asked to find the range or ranges of values of k can take for this equation to have two real distinct roots. So this is a quadratic equation. This equation will have two roots when the discriminant is greater than 0. You are asked to find the values of k for which this equation will have two distinct roots. This is the equation. These are the coefficients of x square, coefficient of x, and this is the constant term. Because equation has two real distinct roots, it is said. So if equation has two real distinct roots, so it means discriminant is greater than 0. B square minus 4ac is greater than 0. Putting the values, we get minus 4 whole square minus 4ac. Simplifying this, we will get 16 minus 20k plus 4k square greater than 0. 4k square minus 20k plus 16, dividing whole expression by, or dividing both sides of the inequality by plus 4, we get k square minus 5k plus 4 greater than 0. Factorize this expression, we get k minus 1 k minus 4 greater than 0. Now we can solve this inequality as we have studied in the previous lesson. These are two factors. So this graph cuts at 2 points, at k is equal to 1 and k is equal to 4. So you can solve this by sketch method, by change of signs, or there are some shortcuts. The required ranges are x is less than 1 or x is greater than 4. This is graph. This is 1, this is 4. You need greater than. Greater than is this, x greater than 4 and x less than 1. Or you can use these rules of solving quadratic inequalities. Rule 1, if x minus a, x minus b, there are two factors, minus, and there is a less than sign, and a is greater than b. Any one of these two will be less than, then x is greater than a and less than b. You can write the inequality in this form directly without sketching or checking the sign. X minus, there should be minus. If there is a plus, you will write minus, and within brackets you will write minus a. Now you will check which one is smaller, and smaller will be written here and larger will be written here. And rule 2 is if x minus a, x minus b is greater than 0, which is in this case, and a is less than b. Now 1 is less than 4. Then you can write a is less than a and x is less than a and or x is greater than b. If this is the case, sign is greater than 0 and one factor is less than the other, the x is less than the smaller one and it is greater than the larger one. If this is the case, when inequality sign is less than and one is less than the other, then you can write this inequality by putting x in between, and it will be greater than the smaller one and less than the larger one. So this is how we can find the values of k when we are said that this equation has 2 or 1 or no root. If it is said that this equation has one root, then find the value of k. We will put this discriminant is equal to 0 and we will find the values of k, which will be k is equal to 1 and k is equal to 4. And if it is said that this equation, find the value of k for which this equation has a no root, so it means when no root, then the discriminant will be less than 0. Less than 0, then it will become this case. Now you can try these using a discriminant. Determine the number of points of intersection of the following graphs with the x-axis. This is the graph. You do not need to draw. You will simply find the discriminant of this. If it is equal to 0, then there is one point of intersection with the x-axis. If it is greater than 0, there will be 2 points, and if it is less than 0, then there will be no point of intersection with x-axis. Now similarly, in this case, this equation has only one solution. you are asked to find the value of k. It is same as we have done in the previous example. Because there is one root, its discriminant will be equal to 0. There are two roots, its discriminant will be greater than 0. Because there is no root, so its discriminant will be less than 0, and you will solve to find the values of k. Exam technique number 7, verify. If you in the question this word verify, this verify, then is often used in a question. When this occurs, you will normally be expected to substitute a value in an equation or statement to check that it satisfies a given relationship or condition. For example, verify that the point 29 lies on the line y is equal to 4x plus 1. So what we will do, we will simply put the values of x and y in this equation. X is equal to 2 into the equation of the line and check that y comes to 9. When you will put x is equal to 2, or you will put this point, the value of x and y, both sides will become equal, which will verify your answer. So this is my profile. Thank you for watching, and Allah Hafiz.